Hey guys, good morning and happy Friday. So let's continue with where we left off last time. So let me go to my whiteboard here. There we go. And what we'll focus on today is the idea of writing equations of functions. It's something that we have not done as a class, so it's right now is the perfect time to do this. So what's going to happen today is we'll be given a picture, and from the picture, we have to provide the equation that goes with that picture. So let me begin by giving you guys all of the cases that we'll look at. For instance, let's say you have a graph that's a linear function. Well, what's the equation that goes with the linear function? Well, probably y equals the very famous mx plus b. There are some extreme cases of lines, like when they run vertically or horizontally, but we'll just assume we have a line with a certain slant or tilt or slope. Now, what if you have a quadratic? Like, what if you have a parabola that can either open up or down? Well, the equation for that one would be y equals a parentheses x minus h squared plus k. And in a different color, I will emphasize this point here in red, because this point in red, if you remember, that is called the vertex. And the vertex coordinates are h comma k. So if you have a parabola, this is the equation you can go to. And the vertex, whether the parabola open up or down, the vertex, that point, the coordinates of it go in for h and k. Okay. What about something like this? What if we have a cubic like that there? Or possibly, let me try that again, draw it a little differently. Something like this, like if you have something like that, or possibly something like this here, where your vertex here in red would be this point here, or that point there. Well, the equation that goes with this one would be y equals a x minus h cubed plus k. So those are three cases so far. So jot that down. If you're not doing so, you really want to copy this down. Let me sort of separate this with a green line. So those are three cases, but let me give you three more, and then that'll be 6 total possibilities. And then we'll do a couple of examples. We won't do like 6 or 7 examples. We'll do like 3 examples. And then that'll be it for this video, okay? So let's see. So those are 3 examples. Here are some more. What if we have a picture that looks like this? Like that there, or possibly like this here. A square root function, as it's called. So for the square root function, the equation is y equals a square root x minus h plus k. That is the equation that goes with that, where here your hk would be this point here in red. I'll always try to have it in red for your hk point. Okay. And then another case is a cube root function. So the picture for a cube root could be something like this here, or possibly something like this here, something like that. See that? Where there, your very special point would be this point here, or this point there. And the equation for this kind of graph would look like y equals, let me just draw it right here, y equals a times the cubic root of x minus h plus k. Okay, and then finally, the last case that we'll consider is the good old absolute value function. Whether it open up or down, the vertex would be this guy here, this guy there. And the equation that goes with that would be y equals a times the absolute value of x minus h plus k. Okay. So those are all the cases. And just some more vocabulary that I can throw at you. So if it's a parabola, we call that special point a vertex. If it's an absolute value, we call it a vertex. But for this one here, for the power of 3, or for the cube root, these guys are not called, it's not called the vertex. Let me just do like in blue here. This point or that point, it would be called POI. This one here or this one here, it would be called a POI. POI stands for point of inflection. Point of inflection, which is something that we'll talk about when we discuss calculus. You know, this one here or this one here, that would be a vertex. And for the square root, I guess you can just call that like an initial point, right? An initial point, like a beginning point, if you will. So these are all of the 6 cases. So we know what equation to use given a certain graph. So let me clear out this whole screen here. You can always rewind if you want to. So let me clear this out. And let's do 3 examples, and then that'll be it, okay? So here are our directions, would be something like write the equation of, let's get this out of the way. And so I'll give you a picture. So let's draw this here in purple. And for our first example, I have them drawn here. So let's go with a picture like this. Like that there, like that there. And then let's go with pink. Let's go like this here, something like that there. Let's put a point here, and let's put a point there, okay? And then let's say that this point up here, up top, it's -5, 7. And let's suppose that, let me just get this out of the way. Let's try to draw that a little bit prettier. There we go, this one. And then let's suppose that this point here is at 1, -2. So let's say you see this on your solo quiz on Monday. You see this picture, you must give them the equation. Well, I'm okay if you guys use your notes on your solo quiz, because this is just memorization. I'm not really a fan of memorization. I'm okay if you have the formulas in front of you. You still have to know which one to use and how to use it. So you don't have to memorize these equations. You can totally use your notes on the solo quiz, okay? So now, look, for a parabola, we know that the template is this one here. Right? We know that it's the squared template, the parabola. We know we have to go here. And furthermore, we know that the vertex, this guy up here on the top, that's our vertex, that's H and K. So we know what number goes in for H and what number goes in for K. So let's make those changes. So let's jot this down again, but instead of H and K, we'll fill in the numbers -5 and 7. So that would look like y equals a, parentheses, x minus -5 squared plus 7. We know what happens with a double negative like that, becomes positive, right? You got a positive. So this is just like y equals a x plus 5 squared plus 7. And then all that's left to find is the number a. Once you find a, you're done and you can move on to the next problem. So to find a, what we do is we use this random point. And let's take that random point and plug in its coordinates in for x and y. Not for h and k. No, h and k is reserved for the vertex. That random point, plug in its coordinates in for x and y. And that'll reveal to us what a is. So let's see. So this becomes -2 equals a, 1 plus 5 squared plus 7. And why don't you guys subtract the 7 to that side from the -2? And that'll be like -9 equals, I'm going to call this 36a, right? 5 plus 1 is 6. The square of that's 36. Divide both sides by 36 and reduce if possible. And a is going to be a -1/4. So what you can do now to finish this problem is take this -1/4 and plug it back in for a right there. See that? So our final answer here in green would be -1/4 x plus 5 squared plus 7. So you want to bubble that in here, right? Sort of box it in. That looks good. And you know what? Look, I believe this because the value for a was negative. which agrees with the fact that this parabola opens down, down, down. Okay, so this was sort of like an entry level example. Now let's do one that's like a medium, and then we'll do one that's pretty gnarly, right? I think we're looking pretty good with time here. We're looking good. So let's clear out this page and let's try example number 2 with the same directions. Okay, we want the equation. So if anything, let me call this example A. Let's pretend that this was example A. And now the same directions, let's try example B. And now here the picture looks a little different. The picture now is going to look like this. Watch. Let's go with a diagram that goes something like that there. And then this special point here is at, let's say, pi, comma, square root 5. There we go. That's that point there, that point of inflection. And then somewhere up above here, randomly, we have a point that's located at pi minus 1, comma, square root 3 plus square root 5, close parentheses. So copy that down. Let me see if I can sort of resize all of this. I'm going to need some space. And let me move this like up here. I think you guys can still see that. Awesome. So let's see, which template, which equation do we use for this picture here? Look through your notes. I mean, if anything, if you want to try this problem without me, just pause the video and then try it and then come back here and here's the explanation. So this looks like a cube root function. So we're going to use the one that looks like this, a times the cubic root of x minus h plus k. And we know that the inflection point is the one in the middle. It's where the graph begins to turn. And that is going to be your h and your k. So plugging in those numbers for h and k, we get this here, watch. We get all this here. It looks like this is what we get, right? When you plug in the inflection point, hk, that's what we get. And it's always this process. You plug in hk, and then you plug in the random point in for x and y to discover a. And let's do that now. Let's take the random point. We'll plug that in for x, and we'll plug all of that in for y. And let's see what that gives us for a. Let's see. So this is going to be square root 3 plus square root 5 equals a times the cubic root of pi minus 1 minus pi plus square root 5. And let's see here. So look inside the radical and look at what happens with the pi. The pi and the minus pi, those knock out, right? Bye-bye, bye-bye. And all you're left with is -1. So let's see. So this is square root 3 plus square root 5 equals a times the cubic root of -1 plus the square root of 5. Well, looking at this equation, guys, look at both sides of this equation. Is there something on both sides of this equation that we can conveniently knock out? It looks like the square root 5s, right? You can just cancel this one without the eliminate. And so we'd be left with square root 3 equals a times the cubic root of -1. But the cubic root of -1 just equals -1. So this is a times -1. And so this is -a. And if you kick the negative to the other side, we discover that positive a equals negative square root 3. And we know where that goes. That goes back in here. So what I can do is erase this a over there. And here in blue, I'll just fill in negative square root 3. Negative square root 3. And I can box that in to get our final answer. See that? That would be the equation. That's the equation that goes with this graph there. Okay. Okay, guys, so let's try one more. And then you guys can use the rest of today to possibly catch up with all your homework, take care of all of that. And then on Monday at the beginning of the class, we'll knock out that solo quiz. Okay. So let's see, let's maybe share my screen here. Here we go. So let me clear all of this out of the way. Bye-bye. And let's try one more, right? The same directions. Example C. Let's see here. Here we go. So the picture looks like this. But let me tell you, I am so glad that we're back in school, like in person, because the last time I did Zoom was, when we were distance learning, and I've gotten used to seeing you guys back in the classroom. And now that I'm doing this video, I feel so lonely. I'm like, wow, I so miss my students. The interaction is so much better when we're in class together. Yeah, so I don't miss this whole distance learning. I'm so glad that we're back in person. Okay, let's see. So this is a square root function. And look for your notes and decide which equation we need. Let's see if I can move this up a little bit, get it out of the way. So look for your templates. And I believe that the formula we want is y equals a. And this is going to be square root x minus h plus k. And we know that the beginning point goes in for h and k. So again, if you want to try this without me, pause the video and just come back to it whenever you're done. So let's see, let's plug in h and k into our h and k model. So this will become, if you do all the double negatives and stuff, it should be x plus square root 7 and then minus e. Okay, if you plug in h and k carefully, double negative inside the square root becomes that. And then we'll take our x and y and plug in those numbers in for x and for y. So let's see. So this becomes like, this becomes 2 pi squared minus e. And then equals a square root 4 minus square root 7 plus square root 7 minus e. Let's see. Oh, like inside the square root, you see the negative square root 7 and the positive? Those are gone. They knock out. Those totally knock out. And furthermore, what else goes away in this whole equation? That negative e in yellow gets knocked out with that negative e in yellow. So let's see what we get here. We have 2 pi squared equals a times the square root of 4. So this is 2 pi squared equals 2a. The 2's knock out. And so a is just pi to the power of 2. So let's take pi to the power of 2. And that goes in for a right here. So our final answer, and don't leave just yet because I have one more thing I want to say. So our final answer would be this here, square root x plus square root 7 minus e. Let's bubble this in. So guys, before you go, just as a way of sort of verifying that you guys were here, if you click on the description of this video, you're going to find a bit.ly. Take that bit.ly, click on it, because it's going to take you to a Google form. And on this Google form, I just want you to sign your name, just as evidence and proof that you were here and saw this video. Okay. So the next time I see you guys will be Monday morning for our solo quiz, and then we'll go from there. Okay. So have a great day, guys. Have a great weekend. See you in a couple days. Bye.